Hello friends, I am Farida and we are discussing today the 7th chapter of physics, 12th standard physics, wave optics. So in this chapter, as its name wave optics, what is optics we should know first. Optics is a branch of physics which deals with the study of light, and so all about light we are discussing in this chapter. In this first lecture, I want to discuss with you the very basic things of light, very primary things of light, which you already have done or learned in the previous standard. That is, what is mean by light, okay, and what are the different properties of light, okay. Then we will discuss what is the laws of reflection, what are the laws of refraction, okay. So actually with the help of this basic introductory part, we will uh, very much close with this wave optics, okay. So one by one we will see about the light. So first of all we will see what is light. Light is the form of energy, and with the help of which we can view the things. Different phenomena in the nature are due to the different properties of light, okay. So which are these properties of light, that we will see one by one in the uh, in the next slide. So this is the slide where we are discussing what are the different properties of light. So first of all, we will see rectilinear propagation of light. What is mean by rectilinear propagation? Rectilinear propagation means light follows a straight line path, and in uh, everyday life we can see the light is coming in a straight form. But if you want to see practically, so the very simple, with the help of very simple experiment, we can get the light is following straight line path. And in the previous standard also we have done this experiment, okay. So it is a candle and cardboard experiment, in which we have taken here the candle and three cardboards are placed, and linear holes are formed on the cardboards, and we can see easily the light is passing through it. And if the one of these cardboard is disturbed in between, then we cannot see the light through it, okay. So light will not pass through it. So this is the small experiment with the help of which we can get the light is following the straight line path. Similarly, if you take a straight pipe and see the light, you can view the light over there. But if the pipe is bent, then we cannot see the light. So from this type of simple experiment, we can conclude that light follows the straight line path. Now, due to this rectilinear propagation of light, the formation of shadow is possible. You can see here in the diagram, if the obstacle is placed in between the path of light and the screen, then shadow is formed over there on the screen, okay. So this is all about the rectilinear propagation of light. Now the next property we will discuss, that is reflection of light. What is mean by reflection of light? Bouncing back of light into the same medium is known as reflection of light. Now here in the diagram we can see the light is coming, light is propagating incident on the plane surface, like suppose it is mirror, and bounce back, okay. This phenomena of light is known as reflection of light. Similarly, you can see here the phenomena which occur due to the reflection. Every day in the mirror you can see yourself, isn't it? So this is one of the example of the reflection of light. Okay, similarly, we will discuss now the refraction of light. What is that? When light propagates from one medium to another medium, instead of going straight, instead of following the rectilinear propagation of it changes its path. This change of path of light when passing from one medium to another is known as refraction. So in this diagram you can see easily, okay, this is the incident ray, this is the normal. These are two media, one is rarer, another is denser. When light is passing here, it should go straight as its rectilinear propagation, but instead of going straight, it changes its path. Okay, now the change of path depends upon the density of the medium also. Okay, so when it is coming from the rarer medium to denser medium, then it changes its path and come near to the normal. Okay, it come towards the normal, and when it passes from denser medium to rarer medium, that time it goes away from the normal. In either cases, there is a change of path of light. Okay, so broken pencil we can see here in the figure. This is one of the example of refraction of light. Then apparent depth of the pond we can see, that is also one of the example of the refraction of light. Similarly, now we will again discuss the next property, that is called the dispersion of light. What is dispersion of light? When the light is passing through the devices like prism, then white light is splitted into 7 colors. Its constituent colors, 7 constituent colors. The splitting of light, white light, into its 7 constituent colors is known as dispersion of light. Okay. Now similarly we will again discuss the next property, that is scattering of light. Now when the light is propagating in the medium where the imperfect medium is there, means many obstacles are there, many particles, small particles are present, then instead of going straight, it deflects. This deflection of light in the medium is known as scattering of light. And now when we know that there are 7 colors of light, isn't it? And each color has its own wavelength. We know very well that red light has more wavelength than the respective colors. Okay, so blue color has less wavelength and red color has more wavelength. Now you can see here in the diagram also, the blue light is scattering more than the red light. It means that the light rays which are having wavelength more, those are reflecting or deflecting less. Okay, so because of this we can see the blue skies, because there is a more deflection or scattering of blue light. Okay, so in this way we have learned the scattering, what is mean by scattering. Now we will go ahead and discuss this next thing, that is total internal reflection. Very interesting it is. We will see the mirage formation. What is that? We will see the image of tree on the road, isn't it? And it is due to the mirage formation. Why it is so? Because instead of going straight, here the light is bending. when it is coming from the denser medium to rarer medium. Okay, so how it happens? What is the total internal reflection that we will see? Here, the complete back reflection of the light is known as total internal reflection. How it takes place, with the help of this diagram we can understand very well. Now, for this total internal reflection, two conditions are very necessary. One condition is the light should pass from denser medium to rarer medium, and second is the incident angle should be greater than the critical angle. Okay, so now we'll discuss it with the help of this figure, and we will understand what are those conditions and how they are satisfying here. So now here, this is the denser medium and this is the rarer medium we have taken in the diagram, and this is the line of separation of these two media. Now we can see here, first of all, we incident the light which is normal to the surface of interval. Okay, so now here you can see this is going straight without any deviation. Now we are making the incident angle. So light is incident here. This is the angle of incident, and this is the angle of incident, and this is the ray of incident. Now when this light is incident, there is a refraction of light. Okay, the ray will refract, and this ray is going away from the normal. Similarly, gradually, if we are increasing the incident angle for the certain angle of incident, instead of going into the second medium, the refracted ray graze on the surface. Okay, or it makes 90-degree angle with the normal. That particular angle of incident for which the refracted ray graze the surface or make 90-degree angle with the normal is known as critical angle. Now, if we increase the angle of incidence more than the critical angle, then what happens here? Instead of going into the second medium, or instead of grazing on the surface, the ray will come back into the same medium. So complete reflection, complete back reflection of the light takes place over here. And this phenomena is known as total internal reflection. So what are the conditions for total internal reflection? The light should pass from denser medium to rarer medium, and the second, the angle of incidence should be greater than the critical angle. Got it? So these are the different phenomena of light. We learn to practice them, to revise them. Okay, just we'll go ahead and we will see the laws of reflection and laws of refraction, which we have learned already. Okay, just we will revise it and see here laws of reflection of light. Now you can see the diagram here very well. Okay, so this is the incident ray, this is the normal. Normal is the line, imaginary line, which is drawn on the reflecting surface, and due to bouncing back, this is the reflected ray we are getting. So this incident ray is making some angle with the normal, and that is called the incident angle. And here the reflected ray also making some angle with the normal, and that is called reflected angle, angle of reflection. Okay, so what is the laws of reflection that we will see? These rays, both rays, means incident ray and reflected ray, as well as the normal, we can see on the same plane. isn't it? So this is the first law. The law states that the incident ray, the reflected ray, and the normal lie on the same plane. This is the first law. And what is the second law? The angle of incident is equals to the angle of reflection. So here in this case, the angle of incidence is I and angle of reflection is R. So mathematically we can see angle I is equals to angle R. So here we can show this in this way. Okay. So just a minute. Okay. So angle I is equals to angle R. Now we will go ahead and we'll discuss the next laws, and that is refraction, laws of refraction. Now in this case also we can see easily the reflection and refraction process. So you can see here, this is the law of refraction, in which it is stated that the ratio of sine angle of incident to the sine angle of refraction for the particular pair of media is constant. Now you can see here, this is the angle I and this is the angle R, angle of refraction. So we are taking the sine angle of I to the sine angle of R, okay, and that is equals to constant. Now here mathematically we can express in this way, sine I upon sine R, that is equals to constant, and this constant is always depend upon the temperature and the wavelength of light. Okay, and the next law we can discuss, that is the incident ray, the normal and the refracted ray lie on the same plane. So students, this is all about the introductory part of this wave optics. Okay, so we will stop here. Have a good day. Stay safe. Thank you very much. And we will meet soon with the next slide or next lecture.